All right, welcome to the nightclub. Here to do our second 9 weeks review. This is a review over chapters 6 through 11. We did a lot this 9 weeks, so let's get busy. All right, number one, we're changing 3.13 radians to degrees. A way to do that is you say 3.13 times 180. Why is it not writing? There it goes. 180 divided by pi. And from there, it's just sticking it in your calculator. So if you have a calculator handy, you just say 3.13 times 180 divided by pi. And you hit enter. 179.335. So we'll just say 179.3, which would be C. Number two, you're changing from radians to terms of pi, or from degrees to radians in terms of pi. So we're doing the other direction here. We're going to say for negative 45 degrees times pi over 180. And so this time, you know it's going to be pi. You just got to figure out what is negative 45 pi over 180. What does that reduce to? So again, you can grab your calculator and just type in negative 45 divided by 180. Notice I'm not putting the pi in. Hit enter and then hit math, enter, negative 1/4. So negative 1/4 pi is your answer, which is D. Very good. All right. Number three, same thing as number two. So negative 180 times pi over 180. This one's actually a pretty easy one. The 180s are just going to cancel, and you're going to be left with negative pi, which is B.
Would you do that without the pi? Like without adding the pi in the calculator?
Yes, I did. I didn't. You don't put when I put in my calculator on number two, you do not want to put the pi, because you know the pi's are in your answers. Okay, you just want the fraction part. Okay. Number four. For a circle of radius 9 feet, find the arc length S subtended by a central angle of 18 degrees. So this is not hard, but you do have to know the formula. To find the arc length S, it is equal to R times theta, and theta has to be in radians. I'll put this up here. Theta has to be in radians. So if it's not in radians, you have to make sure it's in radians, okay? But after that, you just plug in. It tells us that my radius is 9 feet, and my theta is 18 degrees, but 18 degrees, I'm going to change that to radians by saying 18 pi over 180. It's the easiest way to do it. Okay? And then, again, if you look at your answers, they all have pi. So all I'm going to put in is the number part, not the pi part in my calculator. And then hit math, enter. So we had 9 times 18 divided by 180, and hit enter, and then change that to math, enter. A fraction would be 9/10 pi. That's going to be my answer, and that is D. Okay, got it? Easy enough. Number five, to find the area of a sector with central angle 270 degrees and radius of 6.1. So this formula, area, is 1/2 R squared theta. So that's another little formula you need to know. And again, your theta needs to be in radians. Okay? So you need to know this formula here, and make sure you know this formula here. They're the same process. So area is going to be 1/2 My radius for this one is 6.1 kilometers squared times 270. Again, don't put 270, you got to put 270 pi over 180 to change it to radians, because that's what changes it. You multiply it by pi over 180. So, again, notice on this one we are rounding our answer to the nearest tenth, so when you go to put this one in your calculator, you do need to put the pi, okay? So, I'm going to have to go back and forth here. We'll say 1/2 times 6.5, I forgot what it said, it was 6.1, excuse me, 6.1, where'd it go? Here it is. 6.1 times
I need Abby Stockman. for a
270
checkout.
divided by 180. And then don't forget your pi, times pi. So 14.37. So 14.4. Something's wrong. What'd I do wrong? Oh, I didn't square it in my calculator. So let me try all that again. Clear. So we got 1/2 times 6.1 squared times, what was it again? 270 pi divided by 180. There we go. 87.7. So 87.7 is D. Okay. Number 6, amplitude, period, phase shift of f of x equals -5 sine of 7x minus 3. Okay, so the amplitude is the easy part. It's the number that's in the front of everything, and it's always positive, okay? So what number's in the front here? -5, but the amplitude's always positive, so I know my amplitude is 5. So that means it can't be B, and it can't be D. It's got to be A or C, okay? Your period, this is something you may need to remind yourself. It is 2 pi over K, okay? And I guess I should write down this equation. This is A, K is what's in front of your variable, and C is what's on the end there, okay? So the period for this problem would be 2 pi over K is 7. Okay, so right now I know, without even going any further, the answer has to be A. Okay, now I'm going to go ahead and show you how to do the phase shift. To do the phase shift, I'll just call it PS. It's -C over K. So these are some things you may want to remember here, okay? -C over K, so my phase shift would be negative. My C for this problem was -3 over my K was 7, and so that's going to be positive 3/7. So that's why my phase shift was positive 3/7. Okay? All right, next on the back, next page. We are doing the same thing, but we're going the other direction. They give us the amplitude, the period, the phase shift, and the vertical shift. We just have to write the equation, okay? So if you notice, they did the amplitude, they didn't help us at all because they made them all plus or minus 2. That's all correct, okay? Amplitude is the number that's in front, so they're all plus or minus 2 for every one of them. The vertical shift is where I would go next. That's the one that's on the end. It's -3. So which one of those are -3?
B and D.
B and D. So it can't be A or C. It's got to be either B or D. And if you notice, I really don't have to worry about the period. Again, I'm going to do it just to show you, but both of my B and D both have the same thing for K. Okay? So I'm going to find K, but I'm only finding K in order to find C. Okay? So to get my K, I know my period, remember, we just said it was 2 pi over K, and it tells us that the period in the problem is 4 pi. So 4 pi equals 2 pi over k, and you can just switch this 2 pi and this 4 pi and the k. So k is going to be 2 pi over 4 pi, which reduces to 1/2. So k is 1/2. That's why right here. Here's k is 1/2. Here k is 1/2. For my phase shift, again, I'm going to write it down. It's negative c over k. So I don't know what c is. I'm going to say negative c over, I know what k is. I just found it, 1/2. And it tells me my phase shift is negative 3 pi over 2. And so I just multiply both of those by negative 1/2. And that will leave me, the negative and the negative cancel, so I leaves me with positive c, and that would be positive 3 pi over 4. So which one of those has a positive 3 pi over 4?
D.
D. So D is my correct answer. Okay? Easy enough. All right. All right, number 8. At number 8 is when the trig stuff starts to happen. Okay, so if you have your formula sheet, this would be a good time to pull it out and start using it a little bit. It says, what basic trig identity would you use to verify that tangent x cosine x equals sine of x? Okay, well, if you'll remember when we did the trig, what did we always try to make everything into? We tried to change all of them to be sine or cosine. Okay, so the only one that's not sine or cosine is this tangent x right here. So I would change tangent x, and I would change it to sine x over cosine x. So that would be the trigonometric identity I would use there. Number 9, same type question. Little different though this time. Another thing I told you to remember, anytime you see squares, you need to think Pythagorean identities. And so Pythagorean identities are what have the squares. Okay, so right here it says sine squared plus cosine squared equals 1. So that's the one I would use right there. Sine squared plus cosine squared, or cosine squared plus sine squared equals 1. All right. Number 10. It's a little long, but that's okay. Push comes to shove. You're going to have your calculator. So I'll kind of show you the cheat way if it's a multiple choice test on how to do it. Okay. You can literally type in cosine of 15 degrees. You need to make sure your mode in your calculator is in degrees. Mine is in radians, so make sure it's in degrees. And then type cosine of 15 and hit enter. And you're going to get a big long decimal. Okay, your mode was in radians. Yep. Now go back and hit the same thing. There you go. So you get this big long decimal, and all you have to do now is take the answers that you have to choose from and plug those in. So square root of 2 over 2. So let's try square root of 2 divided by 2. Is that the same decimal? No. All right, so let's try the next one. So I know it's not square root of 2 over 2. Square root of 2 plus square root of 6 over 4. Let's try that one. Make sure you put parentheses around this one because you're adding. Square root of 2 plus the square root of 6 divided by 2. Still didn't get the same one. So, can't be B. Let's try just square root of 6 over 4. So, square root of 6 divided by 4. That's a no. So it has to be square root of 2 over 4, but I'm going to just double check, make sure it's right. square root of 2 divided by 4. Oops, I didn't do that right. Square root of 2, get out of the square root, divided by 4. And that's wrong too. So what did I do wrong? Did I do something
I got it
wrong?
wrong too.
It was square root of 2 plus square root of 6, right? Over 2? Oh, it was over 4. It was over 4. So let me go back and try that again. Very, very important that you plug in the right numbers here, because I think that's my answer. So, square root of 2 plus the square root of 4, hit enter, and divide. No, I'm doing it wrong again, aren't I? Square root of 2,
Yeah, there it went.
square root of 2 plus it's the square root of 6, correct?
Divided by 4.
And then divided by 4 is the point. There you go. Cosine of 15. All right, there we go. Same fraction, same decimals there. So I know that's kind of the shortcut way of doing it, using your calculator. So it has to be, answer has to be B. Okay. So I'm going to show you the long way because, I'm a math teacher. That's what I'm supposed to do. So we're going to use, see that's cosine of 15. We're actually going to use a difference of cosine identity. And it simply said that cosine of, what's it say? Alpha minus beta equals, and this is number 9 on your formula sheet. Okay, so it's cosine alpha cosine beta plus sine of alpha sine of beta. So in order to use that, we got to pick two angles that are on the back of our formula sheet, okay, that subtract 15. So I'm not going to make it hard. 45 minus 30 is 15. So I'm just going to pick 45 minus 30. So we're going to say cosine of 45 minus 30. And then we're going to plug it into this. So that would be cosine of 45. Again, 45. This is my alpha. And 30 would be my beta. Okay, so cosine of 45 times the cosine of 30 plus the sine of 45 times the sine of 30. And we look at our chart, and our chart tells us, again, you have this on your formula sheet, that the cosine of 45 is the square root of 2 over 2 times the cosine of 30 is square root of 3 over 2 plus the sine of 45 is also square root of 2 over 2 times the sine of 30 is 1/2. And so that ends up being the square root of 6 plus the square root of 2 over 4, which was our answer. So again, that's the long way of doing it. You won't have to show all that on your exam because there's long enough. The test is long enough, so treat it just like the ACT. You can use your calculator way, but that's the actual way to do it if they weren't giving me options to choose from. Okay. Number 11, we are solving the trig function. So these are actually not too bad at all. 5 tangent of x equals 5 square root of 3. And so we're just trying to get the tangent of x by itself. So just divide by 5 on both sides. And we'll get tangent of x equals square root of 3 because the 5's cancel. And if you've forgotten how to get rid of sine, cosine, tangent, you do it by doing the inverse of them. So x will equal the inverse tangent of square root of 3. I'm basically taking the inverse tangent on both sides. I'm just not writing it on the left side because I don't really need to. And from there, we stick it in our calculator. Second tan of square root, square root of 3, and hit enter, and it tells me my answer is 60. So 60 degrees, which is A. You too, Jay. $12 is a few more steps, but it's very similar. So 2 minus 3 cosine x equals 5 plus 3 cosine x. And we're going to get the cosines together on one side and the numbers together on the other. So I'm going to subtract 2 from both sides. It'll be negative 3 cosine x equals 3 plus 3 cosine x. Subtract my 3 cosine x over to get it with its buddy. It'll be negative 6 cosine x equals 3, because those cancel. Divide by negative 6. So we have cosine of x equals 3 over negative 6 reduces to negative 1/2. And then again, how do we get rid of cosine? We take the inverse cosine of negative 1/2. So grab my calculator, hit second cosine, negative 1 divided by 2, and you get 120 degrees. So 120 degrees, which is also okay. Good. Awesome. All right, moving on. Page 3 or 2, depending on how you're counting your pages. Here we're getting into the vectors. This was chapter 8. Okay. Start of chapter 8 right here was the vectors. It says identify the ordered pair that represents the vector from A to B, and then the magnitude. So if you remember to get the vectors, you're just going to subtract the second one minus the first one. Okay. So vector AB is just going to be 2 minus negative 7, and then 9 minus 1. So that is 9, 8. Okay, so I know right now it can't be C and it can't be B. It's got to be either A or D. Okay? Now we have to find the magnitude. So the magnitude is going to be one of these two. So to get the magnitude of vector AB, if you've forgotten, you take the square root of your two numbers, the sum of your two numbers squared. So 9 squared plus 8 squared. So that's 81 plus 64 is 145. Yeah, you did the square root of it. Yeah, 81 plus. So it's just the square root of 145, which equals 12.0416, right? Which is A. Easy enough? Okay. Number 14 is still vectors. It's a little different. They say 2 times vector u minus 5 times vector v, and they want it in unit vectors. So basically you're just plugging in here. So we're going to say 2 times vector u, which is I minus 5j, minus 5 times vector v. Well, vector v is 2I minus 7j. And from there, it's just basically multiplying it out and adding up. Okay, so we're going to distribute. That'll be 2I minus 10j. God bless me. Gracious. And then distribute the negative 5. We'll get negative 10I. And negative 5 times negative 7j is positive 35j. And then you just add your like terms. So we got a 2i minus 10i would be negative 8i. And we have negative 10j plus 35j is positive 25j, which is A. A lot of A's so far. Okay. Easy enough. 15's the same thing. One difference is it's a triple instead of a pair. So that just means you do everything 3 times instead of twice, just because it's a triple. But basically it's the same thing. We're going to have 3 times vector u, which is negative 4, negative 2, 0, minus 2 times vector v, which is 0, negative 3, and 0. So if I distributed the 3, not negative 3, but the positive 3, I'll get negative 12 and negative 6 and 0. And if I distribute the negative 2, I am distributing the negative with it, so I'm going to change that negative to a plus, okay? So negative 2 times 0 is 0, negative 2 times negative 3 is positive 6, and negative 2 times 0 is 0. And then I add those up, the parts. So negative 12 plus 0 is negative 12, negative 6 and 6 make 0, and 0 plus 0 is also 0. So negative 12, 0, 0, 0 would be C. Okay. 16. 16 is just like number 13, but with 3 of them. Okay. It says find the magnitude, but before we find the magnitude, we got to find the vector first. Okay. So vector wx is going to be, again, just like we did on 13, 2 minus negative 3. And then negative 1 minus 5. And then negative 9 minus negative 8. And we simplify that. That will be 5 and negative 6. And those add up to be negative 1. So there's my vector. And then to get the absolute value of that, or the magnitude in other words, same thing. We're going to take the square root of 5 squared plus negative 6 squared plus negative 1 squared. So that would be square root of 25 plus 36 plus 1. So I believe that is 62, if I'm not mistaken. So the square root of 62 would be D. Okay. 17. Oh, goodness. 17 is the big one. 17 is the one where we had to do the matrix. Okay. They want the cross product here. Okay. The X product. So I'm going to actually, so we have room. I'm going to put it over here. What's 15, right? That we're doing? No, we're doing 17. Excuse me. So 17. This is the one where we make the 3 by 3 matrix. And on the top row, we let that be A, or I, J, and K. And then in the middle row, we let be our first matrix, which would be negative 5, and 8. And I'm getting that from these, negative 5, and 8. Okay, and then my last row is going to be 2, 4, and negative 2. 2, 4, negative 2. Okay? And if you've forgotten how to do it, we let each row cancel each other out. Okay, so if I'm on that row and column, I'm going to write down my I, and I'm going to do the cross product of negative 5, 8, and 4, negative 2. Minus, very important. The J is always minus. Okay, minus J. And I just move my little thing over. If I can get it. I can't get it. So now I'm doing J. So I eliminate J, and I'll write down the numbers for the rest what's left. So negative 5 and 8 are left, and 2 and negative 2 are left. Plus K, again, eliminate the row that K is on, or the column that K is in, excuse me, and write down what's left. So we have negative 5, and 2 and 4 left. Okay? And now we do math. So this is going to be I times, if you forgot how to do it, you multiply negative 5 times negative 2, which would be 10, minus 8 times 4, which is 32. So we're going 5 times negative 2 minus 8 times 4. Okay? Minus J. Here we're going negative 5 times negative 2 again. Hold on. That can't be right. Oh, it is. Never mind. All right, negative 5 times negative 2 is 10. Minus 8 times 2 is 16. Okay. This was minus 32. And this was 10. All right. Last but not least, plus K. K is going to be negative 5 times 4 is negative 20. Minus negative 5 times times 2 is negative 10. And then you simplify all that. So this would be I times 10 minus 32 is negative 22. Minus J times negative 6. 10 minus 16 is negative 6. Plus K times negative 10. Negative 20 plus 10 is negative 10. So my final answer is negative 22I. Negative J and negative 6 make positive 6J, and then minus 10K. And hopefully that's one of the answers. And it is. It is answer number B, letter B. Is that right? Is that right? Negative 22, and then positive 6, and negative 10. Yep. Letter B. All right. So those were chapters, I think vectors were chapter 8. May have been vectors, may have been chapter 9. 8 or 9. All right. 18 starts chapter 10. Talking about the circles, midpoint and distance. So it says to find the distance between points P1 and P2, then find the coordinates of the midpoint between P1 and P2. So, formula alert, you need to know these. Distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Our midpoint formula is just x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So these are two formulas you'll need to know. I don't believe they're on your formula sheet. They may be. I don't think they are, though. Let's look. No, I don't believe those are on your formula sheet. So make sure you know those. And then it's just plugging in. So we're going to have square root x2 is 2. This is here, I'll just label them x1, y1, x2, and y2. Okay? So x2 is 2 minus 1 squared. Y2 is negative 5 minus y1 is negative 3 squared. And basically you just stick that in your calculator. So we're going to have the square root parentheses of 2 minus 1 squared plus, what was it? 2 minus 1 squared plus negative 5 minus negative 3 squared. Negative, parentheses, negative 5 minus negative 3. Squared. Enter. 2.236 is the answer. So this is 2.23 or 2.24, I guess, would be rounded. 2.236 would be 2.24. So right there, actually, do we need to keep going? No, we know the answer is going to be C because it's the only one that's got 2.24 for the distance, okay? But I'm still going to find the midpoint. Midpoint, you would just do 2 plus 1 over 2, and then do 2 negative 5 plus negative 3 over 2. And those reduce to, that'd be 3 halves over negative 8 over 2 is negative 4. So 3 halves is 1.5. So as you can see, 1.5 and negative 4, same answer. Okay? So just in case they give you one that has the same distance. If they just give you one with different distances, then really you just have to do that one. Really, all the distances and all the midpoints are different. So really you just got to find one. So do whichever one's easier. Okay? Slope formula. So slope equals y2 minus y1 over x2 minus x1. There's another formula that you need to have memorized. Okay? And again, you just label them the same: x1, y1, x2, y2. All right? So that's going to be y2 is negative 4 minus y1 is 6 over 2 minus x2 is 2 minus x1 is negative 7. So that would be negative 10 divided by 9, which is C. All right, you good? All right, here's our circle equation. The equation of a circle you need to remember is x minus h squared plus y minus k squared equals r squared. And h and k is the center, and r is the radius. Okay? So it's actually pretty simple. They give us the center and the radius, so we just got to plug it in. But in order to do that, you got to know your formulas. Okay? If I'm not mistaken, I think these might be maybe I'm making this up. I don't know. I thought maybe they had those on your calculator, but I don't think they do. I think I'm making that up. All right. Just make sure you know the formula for the circle. All right. So if my center is H and K, we're doing the opposite of them in the parentheses. Okay. So my center is 1 and 2. So that means I'm going to be X minus 1 and Y minus 2, which is C. It's the only one it can be. Okay. My radius is 5. What is 5 squared?
25.
25. So that's why it's equal to 25. That's all there is to do that. Okay. 21, you're sketching the graph. So it's kind of doing the same thing, just going the other direction. If this is my equation, my center would be what? And again, remember, you do the opposite. So it's not -2, -5, but what?
And +2.
+2 and +5. And my radius is going to be not 9, but what?
-9.
Nope. Remember, this part is equal. It's equal to r squared, right? So if r squared equals 9, what does r equal? You just take the square root of it. It would be 3. Correct. So we're looking for the graph that has the center at 2, 5. So it can't be A and it can't be C. It's got to be either B or D. So 2, let's see here, 1, 2, 1, 2, 3, 4, 5. That center is good for D. And then 1, 2, 1, 2, 3, 4, and 5. So that center is also good. So which one has a radius of 3? Has to be B. See if you count them. It's 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. The radius is 3 all the way around. D, the radius is just 2. Can you see what I'm talking about there? Okay. I'm just counting literally from the center. Okay. So it have to be B. All right, 22. Ellipses. Okay. So we have to change this ellipse to the correct standard form. Right now I know it's not. Which one?
C.
No,
No, wait, what?
oh, wait, you said C? That's correct. It can't be C because C is what kind of shape? We just did them.
Sorry?
It's a circle. Okay, so it can't be C because C is a circle. Okay, and we're wanting an ellipse. Okay, so we're going to take our ellipse formula over here. Let me move. This is 22. 22. Let me borrow yours. So we got 9x squared plus 4y squared plus 54x plus 40y plus 145 equals 0. Okay. And what we do is we get our x's together. So that would be 9x squared plus 54x. And I'm going to put a plus 4y squared plus 40y. And I'm going to move the negative 145. I'm going to move the positive 145 over by making it negative. Okay? Now we got to complete the square twice. 2 times. Okay? But before we complete the square, remember what has to be in front of x squared and y squared in order to do completing the square? 1.
No, what?
Okay? A 1. So I need to get rid of that 9. Okay? So what I'm going to do is I'm going to factor 9 out. So 9 factored out from these two. Okay? So if I factor out a 9, that's going to leave me with x squared plus 9 times what gives me 54? 6. So 6x. And then I'm going to put my plus blank here because that's where I'm going to do my completing the square. Okay? Plus, here I'm going to factor out the 4. And that would be left with 4 times y squared plus 10y plus blank. equals negative 145, and I'm going to put 2 plus blanks over here because I have 2 plus blanks on the left. Okay? So what goes in the blanks? If you remember, we divide this by 2 and square it. So what's 6 divided by 2? 3. Okay, that does equal 3. And then 3 squared is 9. So 3 squared, 9 goes there. But on the right side, we don't put 9 because this 9 is being multiplied by another 9. So over here, we got to put 81 because we actually added 81. Does that make sense? Okay. What about here? 10 divided by 2 would be 5, and 5 squared is 25. But over on the right side, we're actually adding 4 times 25, which would be 100. Okay, and so now we have 9 times, and we can write this as a perfect square now. So it'd be x plus 3 squared plus 4 times y plus 5 squared equals 100 plus 81 minus 145. So 100 plus 81 minus 145
Yes.
equals 36. In our last step, we always want an ellipse to equal 1, so we divide everything by 36. And we reduce. 9 over 36 would be x plus 3 squared over 4. 4 over 36 is 1/9, so that's y plus 5 squared over 9 equals 1. So there's our answer. And we just got to figure out which one of our answers is that the answer. So it looks like it's going to be B. A looks like it, but it has x minus 3 and y minus 5 rather than x plus 3 and and y plus 5. So it's got to be B. That was a hard one. Okay. I shouldn't say hard. It was long. All right. 23. A little easier now. Everything in here in the parentheses is going to the negative 3 power right there. So I'm going to use my calculator. And I'm going to say 3 to the negative 3 power is a big long decimal. And I hit math, enter, changes it to 1 over 27. Okay? So I know this is going to be 1 over 27. When you do a power to a power, you multiply the exponents. So 3 times negative 3 is negative 9. Negative 2 times negative 3 is positive 6. And how do you make a negative exponent positive? You move it to the denominator if it's in the numerator. If it's already in the denominator, you would move it up to the numerator. So I'm going to move that x to the 9th to the bottom with the 27. So that would be D. Okay? Technically, we could have stopped as soon as we found out 1 over 27 because 27 is the only answer that's on the bottom. It's D. Making sense? Okay. And this is starting our last chapter, by the way. This is chapter 11. 24, you can literally put that whole thing in your calculator. Okay? On my paper, it's hard to see. Let me look at your paper. Is that negative? Are they both negative, or are they just a big, long...
I think that is a negative on the negative 4 over 5.
I think they're both negatives, actually, yeah. So we're going to act like they're both negatives and see what happens here. So we're going to plug this in our calculator. Parentheses 243 to the negative, what was it? 1/4. And then we're going to take that to an exponent of negative 4/5. 3, which is B. So that was just calculator. Okay, calculator the whole way, and that is a negative. So on the exam, I'll make sure to look at that closely and make sure y'all got it right. 25, we're solving this, so let me come over here and do 25. It's got a few steps. It's not too bad though. 25, we have 3 equals 9 minus 7 square root of x to the 7th. So we're going to move the 9 first. Be negative 6 equals negative 7 square root of x to the 7th. Divide by negative 7. That'll be positive 6/7 equals the square root of x to the 7th. To get rid of a square root, we square both sides. So that's going to be 36 over 49 equals x to the 7th. And to get rid of the 7th power, we're going to take this to the 1/7 power on both sides. So 36 over 49 to the 1/7 power in our calculator is basically what we're going to put. So let me grab this. 36 divided by 49 to the 1/7 power. You get a big long decimal. You just hit math, enter to get, oh, well, never mind. It must not be a big long decimal. So it would round to be 0.96, right? 0.96, which is A. Okay. 26, 27, and 28. We have our tax problems. Okay. I might let these be bonus on the test, simply because I think we may have, because of time, skipped this section. But you did do them in Algebra 2, I know for a fact, and I think you even do them in Algebra 1. So you have seen them before. It's talking about depreciation, okay? And so here's the formula that you would need to know. It's the amount is going to equal to the principal, or what should I say? Let me say, instead of saying A, let's say V, the value of it. The value is going to equal to the amount you put in times, if it's depreciating, it's 1 minus the percent. Okay? 1 minus the percent to the t power. Okay? Or it's actually, they don't use a p, they use a r actually, because it's a percent rate. Okay? And so all you have to do is know this little formula here and plug it in. They give you everything else. Okay? So what's the amount or that we're starting out with? 17,550,000. That's a lot of money. So 17,550,000. Okay? 17,550,000 times 1 minus, what is our rate?
5%.
5%. So don't put 5, you have to put 0.05. Okay? 0.05 is 5% changed to a decimal. And then to the time power. So how much time?
10 years.
10 years is your time. So this is your R, 5 is R, 10 is T, okay? And basically you do the 10th power, and then you just stick that in your calculator. So I'm going to use your 17,550,000 times 1 minus 0.05 to the 10th power. Enter. We get, what is that? 10,507,833. 10,530,000. There it is. B, right? And again, it's just on your calculator. Okay? Easy enough. Like I said, the hardest part of that is just knowing the formula. Okay? And so like I said, those 3 will probably all be bonus. All right? 27, I shouldn't make bonus because they literally give you the equation. Okay? All you got to do is plug in. So it tells you, let's see here, here's the equation, of course, okay? And it says to model the spread of common corn rust through a field of 8,000 corn plants, okay? They've already got that in the equation. With T equal number of days since the first case of the disease, how many plants will be infected with common corn rust after 10 days? So all we got to do is plug in 10 for T. Okay? So you're going to put in your calculator, you're going to put 8,000 times 1 minus E to the negative 0.03 times 10 power. You just plug it in. Again, 10 is T. Okay? So, let's see here. Go to my calculator again. Clear all that. 8,000 times 1 minus E. To get E to the power, you hit second and natural log, and it should pull up. There you go. And it was E to the negative 0.03. So negative 0.03 times 10 power. Close those parentheses. Nope, not that one. Times 10 first. So times 10. Now close your parentheses. Enter. 2,073.45. So 2,073 would be A. Easy enough. That's some good bonus questions right there. Okay. There'll probably be about, 2 points each. All right. Last one. One more formula to know. It says if the Lafitte family deposits $8,500 in a savings account at 6.75% interest compounded continuously. So this compounded continuously is what makes us have a different formula here. Okay. How much will the account be after 25 years? Here's the formula. Okay. So your Y, whatever you want to call it, will equal the principal times E to the RT power. Okay. It spells out kind of PERT. That's how I remember it. But just remember the R and the T are up here as an exponent. Okay. And so all you have to do, again, this would be another formula that you need to memorize by exam day. Okay. So all you're going to do is say Y equals, my P stands for principal. That's how much money you start out with. Okay. So that'd be 8,500 times E. R again is your rate. So my interest rate is 0.675, but again, don't put, or it's 6.75. Don't put 6.75. You have to move the decimal over twice. Okay. So that would actually be 0.0675 times, what was the time? How much time?
25 years.
25 years. So times 25 years. And so just understand, these are both up here. I'm trying to find, right here. These are both exponents up here that you're multiplying there. Okay? And you just stick that in your calculator. So I'll do it in mine. 85,000 or 8,500, excuse me. Let's try this one more again. 8,500 times E to the point 0.0675 times 25 power. Enter. What did I do wrong? Let me try this again. 8,500 times E to the 0.0675 times 25 power. There we go. Enter. There we go. $45,950.56. So 49,000. Was it 45,000? Uh-oh. What'd I do wrong?
I don't know. I got B.
Did I plug in 45,950? 45. Okay, I'm sorry. I wasn't seeing it. There it is. 45,950. Boom. Okay. Piece of cake. All right. 1, 2, 3, 4, 5. Last 5 are logs. Okay. I saved the easiest ones for last. So 29 says evaluate log base 4 of 1 over 64. So on your calculator, this is a calculator problem. Okay. Calculator. All right. So all you do on your calculator, go to math, scroll up to log base, and it was a base 4 of what? What was it? Log base 4 of 1 over 64. And close your parentheses and hit enter. And you get what?
Negative.
-3. So that is C. Piece of cake. All right. Easy enough. 30 is also a little easy, but we do have to think a little bit. I need to change this to an exponent form. So what's my base? 3. The exponent is the answer on a log form. So it's 3 squared equals x. Well, what does 3 squared equal?
9.
9. So x equals 9. Easy enough. Okay. 31, very easy. You just type log of 0.635 in your calculator. So log 0.635, enter. I get negative 0.197, blah, blah, blah. Negative 0.1972 would be A. It was negative, right? Let me go back and look. Yeah, negative. Okay. For 32, I'm also using a calculator. This time I'm doing the what? Anti-log, which just means you hit what before log? Second log. So second log, let me clear all that. Second log of 2.4624. And hit enter, and you get 290, which would be D. All right, so these are both calculator problems, okay? You are literally doing nothing on your own. You're just sticking it in your calculator, okay? Told you I saved the easy ones for last, all right? Last one on the exam. Oh, wait, I'm sorry. We had 3 more. My bad. Oh, well, it's just more fun, right? All right, so 33, we're solving x to the 3/4 power equals 24. So how do we get rid of 3/4 power? We take it to what? 4/3 power. Excellent. Just like that. Those cancel. So x equals whatever 24 to the 4/3 power is. So hit my calculator, 24 to the 4/3 power. Enter. 69.227. So 69.227 would be 69.23, which is A. Okay? So 3 more. Sorry about that. We have another one. 34 is just a calculator problem. Plug in log base 4 of 11.2. So I'm going to hit, man, I gave you some easy ones last. Math, go up to log base 4 of, what was it?
11.2.
11.2, thank you. Oops. 11.2, 1.4, 1.74. 1.74 is A. Calculator problem is 35. Just plug in natural log of 502. So ln of 502 is 6.22, which is D. Okay. And 36, last one, we got to do a little figure in here. How do we get rid of E? We take the what of both sides?
Square root.
Not
Wait,
square
no,
root.
what-
We just did it in 35. What did we take? What kind of log?
Where did square root come from?
The natural log.
Oh.
Okay? Take the natural log of both sides. And when you take the natural log of something with an e, they just cancel. So you're left with 6x equals natural log of 5.2. And you just divide by 6. And you put that in your calculator. Natural log of 5.2 divided by 6. Natural log 5.2 divided by 6.
Okay.
0.2747. Blah, blah, blah. 0.274. I guess it rounded to 8. So, A. Okay? You good? All right. Hope this helped you at home. Study hard. Stay above the line. And as always, we will see you next time.